Hello everyone, welcome back to channel. So today we will be going to see the navy bias example. So in the previous video we have already seen what is mean by navy bias algorithm, and we have covered the theoretical point of navy bias. What are the different types? What are the examples? What are the types of the algorithm? What are the explanation and theoretical concept of the navy bias algorithm? In the today's video we will be going to see a numerical example. So as you can see, I have listed down the examples here. So here there are some different conditions of the weather, and in that situation whether a person can play or not, the outputs are given here. So to solve the example there are 3 steps. So in the first step we have to create a frequency table for the different classes. So I have written the steps here. We have to create a frequency table for all the features of a different classes. So here there are 3 types of features. The feature is the weather, that is overcast, rainy and sunny, and we have 2 conditions, that is yes or no. So for that we will first create the frequency table. So we will calculate how many overcast situations are there first. So we will calculate here for overcast how many values are there. 1, 2, 3, 4. We have 4 overcast values, and in that we have 1, 2, 3, 4. All are the yes. So we will note it down at here 4. Similarly for rainy, we will calculate the value 1, 2, 3, 4, 5. We have total 5 rainy values. In that we have 1, 2 yes are there, and 3 are the no values. So 2, 3. So similarly we will note it down all the values. So I have done previously only. So the total no values are 3 plus 2, 5, and total yes values are 9 addition. So total yes values are 9 and total no values are 5. So now our frequency table is completed here. We have got total 9 yes values and total 5 yes values. So this is the step 1 in the navy bias algorithm. Now the step 2 is we have to create the likelihood table. So the likelihood table is for all the features against the classes we have to create the likelihood. Now I don't have the space here, so I will be modify the frequency table with the likelihood table. Okay. So I will modify the frequency table with the likelihood table. So we have to modify the likelihood table. Now we have the total values here. Now we know how many total values of yes are there. Okay, now we will calculate the total values. Now here total 14 values are there. If we calculate all the values, we have 14 values. So whatever will be the probabilities, it will be 4 by 14. Okay, so for all these things we have to calculate. Like here there are 3 plus 2. So here it will be 5 by 14. Similarly here also 5 by 14. Here also we have to do the same thing. We have calculated the total here. So for all, we have to add a column here. It will be 5 by 14 and 9 by 14. So here we will get almost 0.36 and the value will be 0.64. I have done the calculation previously, and for this we will get the calculated values are 0.29, 0.36 and 0.36. So this will be our likelihood table. So the likelihood table is calculated based on all the features against the probabilities. So based on all the probabilities we have calculated, based on all the total values of all the total entries in the table, we have calculated these likelihood values. So this was the step 2. Now what is the step 3? Step 3 is the question that we have. The question is, will the player play in sunny weather? Okay. So the condition is given as, will the player play in the sunny weather? Now we have to calculate. Will the player play in the sunny weather? Now we don't want this table. So I will erase it so that we can solve the numerical. Okay. Now we have to find out probability of yes in Sunny. So this is our question. So how it will be? So probability of yes in Sunny will be probability of Sunny yes into probability of yes divided by probability of Sunny. Now here we have all of this probability listed here because we have done the calculation previously only. Okay, how we know that? We have the probability of yes of Sunny because in the Sunny column we have 3 times yes. So we have the probability of yes, means in the Sunny column out of 9 entries there are 3 times yes. So we have probability of Sunny of yes which is 3 by 9. Okay. Again next is we have probability of yes. What is probability of yes? It is 9 by 14. It is 0.64. We have probability of Sunny. What is probability of Sunny? It is total probability of Sunny is 5 by 14 which is 0.36. So we have all of these values. So easily we can calculate the probability of yes of Sunny. So which will be, so we have probability of Sunny of yes is equal to 3 by 9 which is equal to 0.33. Probability of yes is equal to 5 by 14 which is equal to 0.36, and probability of Sunny is equal to 9 by 14 which is equal to 0.64. So if we put all the values into this, we will get the value as 0.64. After all the calculation, we will get the value of probability of yes of Sunny will be 0.64, which is a positive value, and that too which is greater than 5. So it is tending towards 1. So yes, the player will play in the sunny weather. So this will be the output, or this will be the answer to the question. Yes, the player will be able to play in the sunny weather since the value is positive as well as it is tending towards 1 and it is a higher value. So yes, the player will be able to play in the sunny situation. So I hope everyone is clear with the numerical, and one more numerical I will be demonstrating in the next video. So stay towards the channel. Make sure you subscribe it, and for more such videos on machine learning and big data, don't forget to subscribe my channel. Bye everyone.